Got here is a lovely map of the youngest part of our planet, which is our ocean crust areas. What we note here is the youngest material is red and the oldest stuff is this fuchsia color. And there's very few places that have fuchsia, and most of that occurs right here in the Mediterranean Ocean. And if you remember back to some of those early maps, and you can just sort of slide back to them if you choose, is that this was part of the Tethys Sea. This is really old stuff right here, and it just never got incorporated through a subduction zone back into the asthenosphere. There's little spots here and there elsewhere, but nothing substantial, nothing as in mass as there is here. So we've got very, very young ocean crust matter occurring. Just recapping what's happening with Pangaea. Again, this was not the original landmass. We've had land masses which are older than Pangaea. This is the first massive configuration that we know, and that we can accurately map. And at that accurate mapping condition is important to articulate because the Earth is constantly going destruction. And so there were original forms of landmass, but they have long been eroded, subducted, and then put into new matter across the surface of the Earth. So that's really important to articulate that. With those subduction zones, that's the regeneration zone of our planet. That's the recycling zone of our planet. So as I've said, the ocean crust is constantly undergoing recycling because it's really heavy. Because it's heavy, it's going to then slide under that continental crust. So we don't use ocean crust for dating the Earth because it's always going to be younger. All right. Where the ocean crust slides in under continental crust areas, or where two ocean crusts collide together, those are ocean trenches. Those are subduction zones. Those are the deepest part of oceans. The faster and denser a subduction zone rock is, the deeper that ocean trench is going to be. So our deepest ocean trench is the Marianas Trench on the western side of the Pacific Ocean. There are other trenches. They are substantially deep, but they are not moving as fast. They are not currently as active, and they are equally dense, if not sometimes denser than where we've got the Marianas Trench occurring. All right. These subduction zones, when active, and are going to be really high volume earthquake zones and generally high volcanic activity zones. When matter is being pushed rapidly into the surface of the Earth, then the angle of incidence is really sharp. It's diving deep quickly. And because it does that, the relationship between where the ocean trench is and where the volcanoes are is very short distance. When the matter is being pushed slowly underneath the land mass or underneath another ocean mass, then the angle of incidence is going to be shallow. And therefore, the distance between where the volcanoes occur and where the trench occurs is going to be a greater distance between the two. So I'm going to come back to this slide and indicate that the way this artist has drawn it is I've got the ocean trench here. I've got a pretty quick descent. This is where I'm going to get radioactive decay, and I'm going to then, when hot things occur, then they expand. So I'm going to produce pressure here, and that pressure is going to create expulsion and the volcanic matter here. If this subduction zone was more shallow and it was pushing in at a shorter angle like this, then it's not going to reach a depth where temperatures are going to create pressure and expansion until much further along. And in that case, then my volcanoes are going to occur way out here instead. So I want you to think of places like Seattle, Washington, and Oregon. There's a trench off of those two states that sits here, but the volcanoes are way in here. That trench is quite far out to sea, relatively speaking, and those volcanoes aren't very active. The last volcanic eruption that we had in that zone was Mount St. Helens in 1980. Helen is still showing some activity right now, as are Shasta and Hood and Rainier and some of the others, but they're not actively emitting matter. In converse, near the Marianas Trench, the volcanoes look much more like this. There's a quick descent and large volcanic string of land masses emerging. We're seeing the Philippines, we're seeing Fiji, we're seeing Sumatra. All of those locations have active subduction zones where the matter is pushing quickly and creating a string of islands as a result.